Here we have the acceleration of a particle given by this function right here. And note that ln of 4, this is just a constant. This is not a function, so it's just pretty much an exponential function to the power of t. Now it says at time 0, the velocity is 5 feet per second. In other words, the velocity function v of t, which is the integral of a of t, I should say velocity at time 0 equals 5. What is the velocity of the particle when time equals 3? This is what we're trying to find here. So to find this, really all we have to do is the velocity function is going to be the integral of the acceleration function. And we're going to get, I'm going to actually pull out the natural log of 4 in front. It's just the constant again. To the power of t, and we get dt. And this is the same thing as if you were to do the derivative of 2 to the power of t, you get a natural log of 2 times 2 to the power of t. So we have to take the division of that natural log of 2. So we get 2 to the power of t. And then this is going to be plus a constant that comes out from whatever. If you're unsure of why that is the case, just take 2 to the power of t, and you can rewrite this as e the natural log of 2t, but the logarithm lets you take and pull that t out in front. So we get e to the power of t times the natural log of 2. Natural log of 2 is just a constant. Take a derivative of this thing, you can pull the natural log of 2 out in front, and you get e to the power of t times natural log of 2, which is the exact same thing as 2 to the power of t. So that's where the natural log of 2 comes from. It's because of this shift between e of t, you have that constant in there. It's always going to end up being the natural log of whatever the base is, if it's not base e. Okay, so we have this initial condition, v of 0 equals 5, and so this is v of t right here. And so if this is equal to 5, when I plug in 0, I get natural log of 4 over natural log of 2 to the power of 0 plus c. Of course, 2 to the power of 0 is just 1, and that just goes away. It becomes this. Now, natural log of 4 over natural log of 2, this isn't readily apparent what it is, but it's quite easy to find if we just say it's equal to some number x, and then go from there. So I'm going to multiply the natural log of 2 over. I'll do natural log 2 times x. And now I can take e to the power of both sides. So I get e to the power of natural log 4 equals e to the power of natural log 2 times x. Of course, I can just plug this thing into the power of 2. So we get e to the power of natural log of 2 to the x. So this really just becomes 4 on the left-hand side and 2 to the power of x on the right-hand side. And of course, 2 to what power equals 4? Well, x equals 2. So if x equals 2, that means the natural log of 4 over the natural log of 2 just equals 2. So this is just 2 here. The same thing is true for this one. It's just 2. Okay, so that means that c here, of course, equals 5. Or sorry, c equals 3. 2 plus 3 is 5. And this becomes 3 here. And that is our velocity function. So now we're asking, what is v of 3? V of 3 is 2 times 2 to the power of 3 plus 3. 2 cubed is 8. 8 times 2 is 16. 16 plus 3 is 19. The answer is E.